To everybody, I'm pretty sure you have already raised the question I would like to answer today. My question is as follows. How is it possible that a moving body slows down and eventually it stops? And on the other hand, we can study the motion of a pendulum and we can notice that it swings forward and backward and it doesn't stop. The difference has to do with two types of forces, which are conservative and non-conservative forces. First of all, I would like to explain that work can always be converted into kinetic energy. This is what we call work energy theorem. The total work done by all the forces applied to a body is equal to the change of its kinetic energy. So, when we fall down, the work done is positive and our kinetic energy increases. But when a body raises up, the work done is negative and there is a reduction of its kinetic energy. Since friction forces are always opposite to the direction of the motion, the work done by this kind of forces is always negative, so they tend to slow down and eventually stop the motion of a body. But when we study gravitational or elastic forces, which are examples of conservative forces, we realize that the work done by this kind of forces can be converted in two types of energy. Kinetic energy, which has to do with speed, and potential energy, which has to do with the position. Any amount of kinetic energy gained by a body is balanced by a reduction of potential energy. And on the other hand, any reduction of kinetic energy is balanced with the amount of potential energy gained by the body. So, when a body falls down and it gains kinetic energy, there is the same reduction of potential energy, and we check that the total amount of mechanical energy, which is the sum of potential plus kinetic energy, is always the same. So, to sum up, when all the forces applied to a body are conservative, the change of kinetic energy is balanced with the change of potential energy, so the total amount of mechanical energy is always the same. This is what we call the conservation of mechanical energy theorem. See you soon.